Every year, nearly 2 billion tons of steel are produced in the world. China is the world's largest producer, manufacturing 1 billion tons alone. But do you know how this product is made? Watch this video to see all the stages of steel manufacturing, from raw materials to the final product. When you hold a stainless steel utensil, cross a reinforced concrete bridge, or simply open your refrigerator door, you hardly imagine the marathon that piece of metal traveled to reach your hands. Steel, present in almost everything we build, emerges from an encounter between iron-rich rocks, high temperatures, and accumulated knowledge. If you want to witness the incredible transformation from rock to steel, hit that subscribe button and drop a comment telling us what manufacturing process amazes you the most. Steel's fascinating history. Steel has a long and fascinating history, starting thousands of years ago when ancient blacksmiths discovered that adding carbon to iron produces stronger and more flexible metal. Initially, production was artisanal and restricted to small quantities, but in the 19th century, with the Industrial Revolution, fundamental innovations emerged, like the Bessemer converter, created in 1856 by Henry Bessemer, which allowed iron to be transformed into steel quickly and economically. Soon after, processes like the Siemens-Martin furnace and later the basic oxygen converter in the 20th century further accelerated manufacturing, making steel available in large volumes and more accessible. What is steel? Steel is a metallic alloy, primarily composed of iron and carbon, but can also include other elements such as manganese, silicon, sulfur, phosphorus, nickel, chromium, molybdenum, vanadium, among others, to confer specific properties to the steel, like corrosion resistance and the ability to be tempered. Iron or mining. Steel manufacturing begins in iron or mines. The most well-known deposits on the planet are in regions like Carajás in northern Brazil, Pilbara in the Australian desert, and the Great Lakes Belt in North America. In this first stage, excavators dozens of meters high tear out blocks of reddish rock, containing hematite or magnetite. Trucks transport the load to crushers that grind everything into small stones. Next, vibrating screens separate the fine material from the coarser, and giant magnets remove impurities without iron. The objective is to concentrate the metallic content to something that steel mills consider economically viable. Pelletization, the next step, is called pelletization. The ore powder is mixed with water and a natural binding agent, forming small spheres the size of a marble. After being dried in rotating furnaces, these pellets gain sufficient hardness to withstand transport. They board trains, ships, and finally arrive at the plants. Coke production, meanwhile, another fundamental ingredient, undergoes its own transformation. Mineral coal becomes coke. For this, coal is heated in furnaces without the presence of oxygen for about 20 hours. The process eliminates volatile gases and leaves a porous solid, rich in carbon, perfect for generating intense heat inside the blast furnace. The blast furnace. We then arrive at the first monument of steel industry. The blast furnace, a cylinder that can exceed 25 meters in height, lined with refractory bricks. From above, every few minutes, workers pour alternating layers of coke or pellets and small pieces of limestone. At the base, blowers inject air previously heated in ceramic brick regenerators. Inside, temperatures easily exceed 1,500 degrees Celsius. The coke reacts with oxygen from the air and forms carbon monoxide that rises through the furnace column. On its journey, this gas steals oxygen from the iron oxide, leaving behind liquid iron and carbon dioxide. The metal, now called pig iron, descends and accumulates in the lowest part of the vessel, while the mixture of limestone and impurities becomes a slag that floats on it. Periodically, technicians open a hole in the refractory wall and witness a luminous river flowing into channels and then into torpedo cars. These cars are true thermal bottles on rails, insulated with special bricks, capable of keeping the metal in liquid state during the journey to the second key equipment, basic oxygen converter. The basic oxygen converter, known by the acronym BOF or LD. Inside a steel ladle externally and brick lining internally, the pig iron receives a jet of pure oxygen blown through a tube called a lance. In less than 20 minutes, the reaction reduces the metal's carbon from about 4% to values close to 0.1%, transforming the pig iron into steel. At the same time, new slags form that absorb sulfur, phosphorus, and other undesirables. Electric arc furnace. There is, however, an alternative and increasingly popular route in steel mills for forming steel, the electric arc furnace. In it, the main raw material is metal scrap, beams from demolished buildings, press cans, discarded car engines, which pass through magnets, shredders, and equipment for oil removal. Graphite electrodes descend onto the scrap pile and create electric arcs so bright they resemble lightning. Temperatures exceed 1,700 degrees Celsius, melting everything in a matter of minutes. This form of production doesn't need coke or limestone and allows for recycling practically every steel residue produced by society. Secondary refining. Both the steel fresh from the basic oxygen converter and that from the electric furnace proceed to what's called secondary refining. There, inside ladle furnaces covered, a vacuum system removes dissolved hydrogen and nitrogen, while argon jets bubble to homogenize the temperature. Calibrated additions of manganese, chromium, nickel, or niobium define specific properties. Some steels need to resist weather conditions. Others must withstand extreme heat or, conversely, serve cryogenic tanks. The final composition obeys an international standard, guaranteeing that the product reaches the buyer with predictable characteristics. Continuous casting. With the liquid part finished, it's time to solidify the metal. The dominant method in the world is continuous casting. The steel flows through a water-cooled copper mold, forming a solid outer shell shortly after leaving the nozzle. As it descends through rollers, the piece takes the shape of a slab, square billet, or rectangular block. Hydraulic shears cut precise lengths while the interior is still orange-red. It's a hypnotizing spectacle. Incandescent blocks of dozens of tons sliding, as if they were bars of soap emitting white smoke from steam. Hot rolling. In the next stage, these slabs, still hot and are hot rolling. A battery of rollers compresses a material, elongating and thinning it. Each pass reduces the thickness a little, and water jets control the temperature to prevent the surface from burning. In the end, the slab becomes a long strip rolled into a coil, a construction rebar, or a profile. Heat treatment. With the shape defined, steel can receive heat treatments. Quenching followed by tempering hardens parts for tools. Protective coatings to face iron's greatest enemy, rust. Coatings emerge. Hot dip galvanization immerses sheets in liquid zinc. Industrial painting applies epoxy or polyester layers. For food applications, a thin tin coating keeps cans free from contamination. In the automotive sector, complete electrodeposition lines create a protective film before final painting. Global logistics. After being released, the material follows through global logistics. Coils travel on dedicated ships, protected against sea spray. Rebars arrive by train at distribution yards. And that was today's video. Don't forget to leave a like and subscribe to the channel. Drop a comment below and let us know which industrial material you want to see manufactured next, aluminum, titanium, or something else. We're reading every comment.